Hello, today I'm going to talk about Uber Cadence and a proof of concept application which I wrote in order to understand how it works and what benefits provides. I'm still writing the post. You can see it here that it's not published yet. So after I finish recording this video, I will publish it on dev.to. So I didn't start this proof of concept service from scratch. What I did is I modified an existing proof of concept which I wrote for two previous dev.to posts. Here it is. This is the diagram of the original service. And you can see that we were using a materialized view. This is part of Kafka Streams. So we were using Kafka Streams to keep the state of the application, of the service. So but what is the state? Okay, so the application is very simple. It just keeps track of the balance of accounts, right? We have several, let's say, bank accounts, and we receive incoming transfer messages. And if the amount inside this transfer message is a positive number, it means that we need to credit the account, so we need to increase its balance accordingly. If the amount inside this transfer message is a negative number, we need to debit the account, so we need to reduce the balance. So now what we are doing is like we are bringing Uber Cadence into the picture, so we don't use Kafka Streams anymore. You see that we use Cadence server and Cadence workers. More on the architecture of Cadence will come in a little while. And why are we doing this? Why are we replacing Kafka Streams local store with Uber Cadence? So that's something that I'm going to show you in a little while. Okay, but first, let's answer this question. What is Uber Cadence? So if we go to the main web page, here we have the link. So we can see that Cadence fault-oblivious stateful code platform preserves complete multi-threaded application state, including thread stacks with local variables across hardware and software failures. It greatly simplifies coding of complex stateful distributed applications. Okay, those are a lot of words, but the main thing to remember is that Cadence preserves application state. Okay, if we go to the use cases, preserving the application state when in a distributed environment has many use cases. The main one, actually, in the original one, is this one, microservice orchestration and Saga. Actually, the typical example is Uber Eats, right? This is a real example that Cadence is used for. So this is actually from a video by the lead developer of Cadence at Uber, Maxime Fativ. I'm sure he doesn't mind that I saw this here. He's a really nice guy. So you see, this is a workflow, right? I mean, funny enough, if we go back to the Cadence main website, you see cadence workflow.io, right? So what is a workflow? A workflow is a series of steps, series of operations, such as these ones, right? There is a business transaction, which is, someone ordering food, and then that food being prepared and being delivered to the customer. And this transaction spans several microservices, right? Here we have it. From the same video, we can see that we have 4 different microservices. And we use Cadence, I mean, they use Cadence at Uber in order to orchestrate the interactions between those microservices. But in my case, my proof of concept is not about this. It's not about keeping the state of a transaction which spans over several microservices. I'm using Cadence for this. Actually, here we have it: event-driven application. All right. So I'm gonna use Cadence to keep the state of the application, and as I said before, to keep the amount of money always up to date, the amount of money which is on each bank account. Okay, so it's time to get our hands dirty. I have prepared a demo in order to show you Cadence and the proof of concept application. So as you can see, we need Kafka. We are still using Kafka for messaging and asynchronous communication, but we are not using Kafka Streams though. We are using Cadence for that. And so we need Kafka, which I'm gonna use the Confluent platform for it. Then Cadence, obviously, Cadence workers. And this is a Java service, the Cadence transfer recording service, which kind of acts like a pipe between the transfers topic and Cadence. And then we also need these other Java services, which I coded. This is also kind of a pipeline, a pipe between the account balances topic, which provides up-to-date account balance change data, and the Angular frontend, right? So, okay, let's start by exporting the required environment variables. And now I'm gonna start the Confluent platform. This is the command. And this will start Zookeeper and also Kafka. You see that it's starting up. Okay, it's up. Now I'm gonna go to the my Confluent home directory, and I'm gonna start the schema registry, right? So this is the command. And why do we need this? We need it because Kafka needs the schema registry in order to serialize and deserialize the payload of the Kafka messages. I mean, we could use JSON, and we didn't need this. We could also use Google protocol buffers, for instance, but we decided to use Apache Avro for serialization of the Kafka messages payload. And for that, we need the schema registry up and running for Kafka to know how to serialize and deserialize the objects. Okay, so we have it up and running. Now I'm gonna add another, on a different terminal tab, I'm gonna start the Confluent Control Center web application. So this is the command. Here it is. So it's already started, and I can go to the following URL. Let's do it here. And now it's coming up. So you can see that this is my Kafka cluster. I go there, and actually I'm gonna create the required topics. So again, transfers, and since this is just a demo, low availability, it's enough. Save and create. And one more topic, which is gonna be account balances, okay, and the settings again, low availability, so just one partition. Here they are. We can see that there are no messages yet, as expected, right? Okay, so now it's time to start a Cadence. So I'm gonna use Docker for that. So let me start the Docker service. And now let's start the Cadence Docker containers. So it has started. And we can see that we have like 4 containers, the Cadence server, then there is Facebook Cassandra as the NoSQL database, which is used under the hood by Cadence, the Cadence Web UI, and this is for statistics, I guess. Okay, so let's open the Cadence Web UI. This is the URL. And we need to select a domain. My domain, which I created yesterday, is domain 01. Here we go. And you see that it's a workflow which is in open status. So this is an account. Remember, a workflow represents an account. So a workflow is gonna stay open as long as we don't close the account. And it's gonna be processing events, which are transfers, which mean that the balance of the related account is gonna change as per the transfers amount. So we click on the run ID, we can see that it was started yesterday, February 29th. And you can see we can even run queries, but you see it's not loading, right? We can also try to run a query using the command line. Everything you do on the web UI, you can also do it through the Java API or the Go API or the command line, which actually uses the APIs under the hood. First, I'm gonna export environment variable, so I don't need to type the domain name every time I run a command on the Cadence CLI. So now I'm gonna try to query the workflow that we saw on the web UI, right? Account 11. And you see it doesn't work either. The reason why it doesn't work, you see timeout, it's because we have started Cadence server, but we haven't started any workers, any Cadence workers. So I need to start some workers. So to do it, I'm gonna run some Java processes, which are going to run the workflows. And you know, the workflows will get assigned to workers through the Cadence servers. So let me start it. Is this workers creators main. So I created is just one process, but with several threads, and each of those threads represents and acts as a Cadence worker. So now, if I go back to my CLI and I run exactly the same command, get balance, you see that I see the balance. Balance is 1, right? So in addition to the get balance query for the account 11 workflow, we can also submit the get transfers list. And you see there is just one transfer, and we can see that the version is 1 in the previous command output. So version 1 means that there has been only one transfer for that account balance. So the transfer basically says add 1 to the account balance, and that's why the balance is 1, right? So let's go back to the Cadence web UI, and now it should work. So we have our workflow. Let's click on the run ID. Let's go. Actually, we can see the history. This is nice that we get all of this for free, right? You see that it got the following transfer, right? So this is kind of like audit information that for our business purposes, we can run this query, for instance. You see, it's exactly, this is JSON format, it's exactly the same response which we got using the command line, right? It's the same query, get transfers list, one transfer for account number 11, and here exactly the same transfer. So that's cool, but we still need to bring up more services, right? So we have Kafka app, we have Cadence up and running as well, because we can query. So that means that we also have the Cadence worker threads, but we are missing this, the Cadence transfers recording service and the transfer WebSocket service. So let's start those. So if I go here, Cadence transfers recording service. It's gonna start. This is this service, and now the WebSockets service in Cadence mode, right? Because this service existed in the previous post, in the one we were using Kafka Streams, but we are not using Kafka Streams anymore, so I modified the microservice in order to use Cadence. That's why this Cadence mode that you can see there. So if I go there and I run WebSockets service main using Cadence Eclipse run configuration. So I started as well. Okay. That's nice. But what else do I need? Let me see. Okay, of course, I need the front end, right? I need the Angular front end. So I need a WebSocket service so the Angular clients can connect to it, right? Let's do that. Okay, so let me bring up my VS Code. I use Eclipse for Java coding and VS Code for TypeScript. So I'm just gonna compile and serve and serve the application. Okay, it's compiling. In the meantime, actually, I'm gonna initialize some new accounts, some new workflows, right? So here, what I can do, this producers tester, I'm gonna send the initial transfers, which is gonna initialize 5 new accounts. Here we have it. Send initial transfers for account 21, 22, 23, 24, and 25, right? A transfer with amount 0 means that we are opening the account, that the account didn't exist, so we are opening it, and then we are gonna send you know, just some amount to see. So let's do that. Here is send transfers, and we can see that we are sending this to Kafka. From Kafka, it's gonna go to Cadence, and from Cadence again to Kafka, to the WebSocket server, and all the way to the front end. But let's see, Okay, compiled successfully. So the server is running for the front end. So we can open a new browser tab. For instance, here. Now let's do it here. And here we have the front end. So remember our account number 11. Yeah, the balance is 1 and it has only one transfer. You see exactly what we were seeing also on the Cadence web UI. So this is good, right? On top of, fault tolerance and retry logic. We don't see that in this case because this is a small POC application, but we can see that we have the web UI and that's good. We have this just for free, and we can see that what we see on the Cadence web UI matches what we see also on the application web. Okay, let's go back to the application web UI because this is a real-time application. So we want to see the data flowing, right? We want to see the transfers appearing here and also the balance of the accounts getting updated automatically. So for that, we need input data. We need a flow of data coming, and to do so, I have this little tool which sends random transfers to different accounts approximately every half a second. So let's execute this, okay? Here it is, random transfers producer main. So it's starting, and let's go to account 21, for instance, and you see that it's already getting a lot of transfers. You see 184, 185, and you can also see that the balance gets updated automatically, right? So yeah, we could also do it on a different tab. Let's say here, and I don't know, account number 23, and the same, a lot of accounts, a lot of transfers, and the balance gets updated automatically. You can see it. Yeah, we can open as many tabs. So we see that it's working, right? That this is a real time application. And it's good to remember, yeah, that here it is. The transfers are coming through a Kafka topic, are getting processed through Cadence, then back to another Kafka topic, which takes care of broadcasting the account balances changes to the Angular frontend. And that's what we have here. So let's go back to the Cadence web UI. Here we have our workflows. Each one of the workflows represents an account. So let's click on one of them, and we can see we can query it, for instance, to see the list of transfers, and we can see all of them, right? Exactly the same information that we were seeing on the application's web UI. But we can also see the history. That's something that Cadence provides a lot of visibility. You see exactly what happened at any given point of time. And in Kafka, we can have some visibility. If we go to the Confluent Confluence Control Center, and we go to the transfers topic, let's see the messages there. So let's see, from the beginning, here we have the messages, and we can expand them, right? It's exactly the same information, but here we have all the messages. Independent of the account, we have all of them in the same topic, right? If we go to the account balances, we will see the same info, but for changes in the balance of the accounts. In Cadence, Cadence provides more visibility. We can see this is one of the advantages of Cadence. In addition to fault tolerance that it provides, and also retry logic, and especially preservation of the state, that's the main feature. So we also have a lot of visibility that by having just messages in a topic, we don't have that type of visibility. Okay, that's all from my side. I hope you liked the video, and I hope you also stay tuned and watch one of the next videos. Thank you.